Today we're looking at something called parametric equations, and this is going to be when we have one equation that tells us the x and then a totally different separate equation that tells us the y. Instead of one equation that relates the x and y, there's two separate equations for the x and the y. And we have these when there's a third variable we call the parameter. That's where parametric comes from. That we're interested in, or that is going on here, that tells us the x and the y. The most common thing is time. So we might know our horizontal position at a certain time and our vertical position at a certain time. And there might not even be much of a relationship between the horizontal and vertical positions. What the relationship is between time and our horizontal position and time and our vertical position. So if we want to sketch these, just like anything, if we're not sure how to sketch it, we just make a table. So this one we do have what's called a parameter interval. We have specific values of t. Sometimes we have this, sometimes we don't. If we didn't, then we would just choose our own values of t. But this tells us the values of t to have in the table. And so we just take these values and substitute them into the different equations. So I'll do all the x values first so that I can use that same rule there. So I'll take -2, plug that in there. 4 minus 4, that'll be 0. And then 1 minus 4, that'll be -3. 0 minus 4, -4. 1 minus 4, -3 again. 4 minus 4, 0 again. And then 3 squared is 9. 9 minus 4 is 5. And then to find the y's, make sure you remember to take the t values and plug them into this equation. Don't use the x values. So I'm still using t as -2 in there, -2 over 2. That's -1. And then I'll get -1/2. And then 0 over 2. Again, remember, look at the t values here. 0 over 2 is 0. Then we'll have 1/2. 2 over 2 is 1. And 3/2. And so then when we look at this now to graph this, we're still just going to graph x and y. So the t now is kind of going to be hidden. We're not going to see the t values on the graph. We're only going to see the x's and y's. We're just going to turn these into points. 0, -1, just like normal, x, comma, y. The t doesn't really matter anymore too much as we graph this. So we just take these x's and y's and plot those points. So 0, -1 is down there. -3, -1/2, something like that. -4, 0. -3, +1/2. 0, 1. And then 5, 3/2 is 1/2. And so we've got this curve here. And I'm not going to draw arrows at the end because I have a particular parameter interval. This just starts and stops right there. The only thing you will see sometimes to indicate the t values is sometimes we'll put arrows along the graph to indicate direction, to say that this was our first t value, that was our last t value. And so we'll have arrows along the graph showing what direction the curve is moving. You can also graph these in your calculator. If you look in your calculator, if you go to your mode, there's a parametric mode. PAR stands for parametric. If you hit that mode button right there, you can change from function to parametric. And then if you hit that y equals button, it's not just y equals anymore. It has both x equals and y equals. So if I want to graph these, this button that we've been using right here next to alpha, you've probably been using this for x, but notice there's different things on here based on which mode you're in. When you're in function mode, it's x. Now that we're in parametric mode, it's going to be t. So I can hit that button for t. I'll have t squared minus 4. And then down here, I can, again, use this button next to alpha will always be your independent variable, whatever mode you're in, and t divided by 2. And then I did have this parameter interval that I needed right there. If you go into your window, you'll see a few extra lines in there for t values. And so I'm going to go from -2 to 3. Make sure your t-step is something around 0.1. If you're in degree mode, I think that'll be like 7.5 for you, and that's not going to be good. You want to make sure your t-step is something like 0.1 so that you get enough points on the graph. Then if we hit graph, we can see that graph right there. All right, so then what we're going to ask you is to find some different t values corresponding to different points on the graph. You'll see a lot of these talk about particles. In real life, we often use these for things like baseballs or rockets or something like that. But talking about a particle frees us from trying to make it realistic. So we don't have to spend time on fine-tuning those problems like that. So if we want to find the time t when the particle has an x-coordinate of 5, that means we want this x equation to equal 5. So we want t cubed minus t to equal 5. Well, we're going to have trouble solving that by hand, and so we want to solve that in our calculator. The problem is when you're in parametric mode, if you go to your calc menu, if you do second trace to go to that calc menu, a lot of that good stuff that you're used to using is not there anymore. Parametric mode, unfortunately, doesn't have calc 0, calc intersect, or even max or min. So there's a workaround, though. You can just go back to function mode. Notice there's only one variable in this equation that we're trying to solve. So solving this would be the same thing as solving x cubed minus x equals 5. So we can just solve that in function modes in the calculator. It's just kind of a workaround, a trick. Even though really this is a parametric mode problem, for this problem right here, the y doesn't matter. So there's really just one equation that we're looking at. So I'll change my mode back to function. And then I will type this in here. Just instead of typing t, I have to type x because I'm in function mode. So I have to type x cubed minus x. And then just like normal, you can either do calc 0 or calc intersect. It's up to you. You could either subtract the 5 and do calc 0. I'll just graph the 5 separately, and I'll do calc intersect. So second trace calc, fifth choice there is intersect. I should see that they cross in a nice spot right there. So hit enter a few times, and there we go. All right, now keep in mind we switched the letters around. So here the calculator is saying y equals 5. It's really an x of 5 that we were changing. And then this x right here, this x is really the t. Where I wanted to say t, I had to say x. So the letters get kind of changed around, but we're just trying to solve an equation. So here's our answer right there that we wanted. The answer to the equation is about 1.904. So same thing if we wanted a y coordinate. So now it's the y equation that's going to matter, and the x equation we're not going to care about at all. We just want t plus natural log of t to equal 7. And I just want to solve that equation. It doesn't really matter what letter that is. Solving equations we can do on our calculator. We did this way back in chapter P at the beginning of the class. And back then you probably wouldn't have cared too much what letter I gave you in the equation. You would have just solved it. So we just change our letter, whatever letter this is in the equation, change it to x. And then again, either subtract the 7, do calc 0. You can maybe do that on this one here. Just have to make sure I close that natural log of x parentheses right there. And so if I've subtracted the 7, now I can do calc 0. And I'll need a left bound, and then a right bound could be something like 9. Hit enter again, and there's my answer. Again, the calculator thinks it's x, but really it's t that I found right there. The letters just kind of get switched around. But I'm just solving an equation, just like we've done all throughout the class. It just so happens that there's a different letter in the equation. Again, what we're doing is we're solving x plus natural log of x equals 7 in the calculator. Right? So those are calculator problems. Again, just using this workaround here using function mode. Right? These down here we're going to be able to solve without our calculator. So we're going to try to find when it's at the origin. Well, being at the origin, we know what the origin is. The origin is the point 0, 0. Well, if you're the point 0, 0, the key is that x has to be 0 and y has to be 0. They both have to be 0, not just one or the other. So I'm going to solve both of these. And I'm going to look for an answer that works for both of them. So I'm going to have here t times t minus 1 is 0. That's t is 0, or t is 1. But those t values just tell me x is 0. That would just be places on the y-axis. Could be anywhere on the y-axis, anywhere where x is 0, not necessarily the origin. To be the origin, I need my y to be 0 as well. So I'll factor this one as well. That should be t plus 6, t minus 1 is 0. So I get t equals negative 6, and t equals 1. So these two t values are the places just where y is 0. So this tells me for these I'm on the x-axis, but I don't want to just be on the x-axis. I don't want just y to be 0. I need both x and y to be 0. Well, that happens at t is 1. So my only solution here is t equals 1. We're looking for t values that are solutions to both those equations. So same thing down here. You'll just notice that there's something kind of funny in here. I started making these problems with this funny little thing in here because I found that some students were taking the two equations and setting them equal to each other. And they often got the right answer, even though that's not quite the right process. Because, of course, if both x and y are 0, then, of course, x does equal y. And so a lot of times it worked for them. The problem is if you just take the two equations and set them equal to each other, maybe you're finding a time when it's the point 2 comma 2 or the point 7 comma 7. You wouldn't necessarily be finding 0 comma 0. So I started making kind of funny problems like this to force students to actually solve both equations being equal to 0. Not if you try to set these two things equal to each other, you'd have some trouble. So this one, even though it looks funny, it's actually pretty easy because it's already in factored form. You're just using your zero product property. Either t minus 2 has to equal 0, or this whole funky thing has to equal 0. The exponent doesn't matter. If this part is 0, 0 to any power is 0. So you would just be looking at t plus square root of pi equals 0. And so you'd have t equals 2 and t equals negative square root of pi. Of course, if you want, you can kind of ignore this part here because you can probably see that this funky solution over here is not going to work for the x equation. So again, I do need both x and y equal 0. So I factor this one. T minus 2, t minus 6 is 0. Either t equals 2 or t equals 6. The only t value that makes both x and y equal 0 is 2. And so our final answer is t equals 2. And that's it.